Use a graph and the following clues to determine which hikers meet on the trail. They all departed the parking lots at the same time. The Welcome Center is 900 yards from parking 1 and 720 yards from parking 2. Ashley and Michael leave parking 2 and travel at 60 yards per minute. May leaves parking 1 and travels at 90 yards per minute. And Mr. Nelson leaves parking 1 and travels at 60 yards per minute. So we know that I've got a line graph at the bottom there. 900 is where we need to go, and the distances between parking lots 1 and 2 and their overall distance to the final part, to the Welcome Center. Michael and Ashley are traveling together, so they have a head start on location than the rest with Mr. Nelson, May, and May. So they're at 180-yard advantage. So then after the first 2 minutes, Mr. Nelson travels 60 plus 60 per minute, so 120 yards. May travels 90 and 90, so 180 yards in 2 minutes. And then Michael and Ashley travel 60 yards per minute, so 180 plus 120 gives us 300. So following in our path, doubling Mr. Nelson and May for another 2 minutes and adding 120 for Ashley and Michael, I see that May is quickly approaching Michael and Ashley, but Mr. Nelson is still far behind. At 6 minutes, I see that Mr. Nelson has traveled another 120 yards, while May has finally caught up to Michael and Ashley and will now surpass them because she's walking a little bit faster. She's traveling 30 yards per minute faster than Ashley and Michael. So now she's overtaken them at 8 minutes, where Mr. Nelson is still behind. So we can write an equation for each one of their travelings. Michael and Ashley travel at a rate of 180 plus 60 yards per minute, where T is time. May leaves parking lot 1 and she's traveling 90 yards per minute, so per minute, so times time. And then Mr. Nelson is traveling at 60 yards per minute. So converting these into a graph, I see that Mr. Nelson, who is this green line, will never catch up or intersect with Ashley and Michael or May. I see that this blue line is Ashley and Michael since they have a head start at 180 and they're traveling. And then finally May will surpass them. Their paths are marked off, and the location where they intersect is where Ashley and Michael meet May. The graph and equations represent how much water remains, G, in two fountains during the time in minutes they are being drained. Fountain A is at a rate of 250 minus 25 T, and fountain B is being drained at 220 minus 20 T. Classify each statement as true or false. Assume the fountains begin draining at the same time. Pause the video and answer true or false, and then we'll talk about them. Fountain A has more water remaining than fountain B until they are both drained completely. This is false. At one point in time, fountain A will have less water remaining because where they intersect here, then all of a sudden, as we move forward, fountain A starts to have less water than fountain B. Fountain B drains at a faster rate of gallons per minute than fountain A. This is false. I can see above that fountain B is draining at 20 gallons per minute, where fountain A is going at 25 gallons per minute. So it is draining, fountain A is draining faster, has a faster rate. The fountains will have the same amount of water at 6 minutes. So at 6 minutes, I see this is where they intersect. So this is true. When fountain A has 100 gallons of water, fountain B has 100 gallons of water. That is true. Where they intersect at 6 minutes, they both have 100 gallons of water remaining. We can solve systems of equations algebraically as well as graphically. Let's say we know the price of a pepperoni pizza is $1.25 more than the price of a cheese pizza. Let's use a system of equations to finish this purchase order. Let's let P equal the price of a pepperoni pizza and C be the price of a cheese pizza. Here we have 14 pepperonis, 16 cheese for a total of 20 pizzas. We don't know their price per unit, but we do know that it costs us altogether $242.50. So here are some things we know. The price of a pepperoni pizza is whatever the price of a cheese pizza more than or plus $1.25. We also know that 14 pepperoni pizzas plus the cost of 6 cheese pizzas has to equal $242.50. Since I know what P is, I can put in C plus 125 where I see P in the second equation. So 14 times $1.25 plus C is equal to 6C, which are plus 6C equals $242.50. I can distribute the 14, giving me $17.50 plus 14C plus 6C equals $242.50. Combining like terms, I have 20C plus 1750 equals 242.50. Subtract 1750 from both sides gives me 20C equal to 225. Divide by 20, C equals 11.25. So a cheese pizza is $11.25. We can then find what a pepperoni pizza is by inputting 11.25 into the pepperoni equation. So pepperoni is equal to 11.25 plus $1.25. So a pepperoni pizza is $12.50. We now can finish our chart. Because we know that a pepperoni pizza is $12.50, a cheese pizza is $11.25, so altogether would be $23.75. I can then figure out my subtotal category by taking 14 times $12.50 for $175, 6 times $11.25 for $67.50, and adding each subtotal in each subcategory, I can see that altogether we balance out at $242.50. A movie rental company offers two options for its customers. The digital movie option costs a monthly fee of $3 per online rental. The DVD option costs a monthly fee of $10.50 per rental. When will their options be the same and at what cost? Let's let X represent a movie rental. I know that then for the online rental it costs 3 times X and that the DVD option is the base fee of $10 plus 50 cents per movie. I want to know when these options will be the same, so I will set them equal to each other. I will subtract 50 cents times X from each side, giving me 250X equal to 10, divide by $2.50, so X equals 4. The two options will be the same when I plug 4 into each option. So when we rent 4 movies, and the total cost then would be 3 times 4 or $12, which is the same cost at 10, the base fee of 10 plus 50 cents for 4 movies. The options will be the same, renting 4 movies at a cost of $12. Your homework, you will explore on your own exponents. Part 1. Use the digits 1 to 9, at most 1 time each, to fill in the boxes to make a result that has the greatest value possible. Use the digits 1 to 9, at most 1 time each, to fill in the boxes to make 2 true number sentences. And can you find the third possibility? Not repeating any of the digits. So you can reuse 1 through 9 in each part individually. So the 1 to 9 restarts after each part, I should say. When you have your solutions to both parts, scan and upload your results to the Exponents discussion board and take a moment to view and comment on at least one classmate's responses. Print the homework included in the Practice Problems homework Dropbox. Complete the problems as outlined within the homework pages, taking care to show all of your work. Scan and upload your documents back into the Practice Problems Dropbox.